Hi, this is Dr. Simon Romero. I'm here to present you the video tutorial for triple integrals over rectangular boxes. So first of all, what is a rectangular box? A rectangular box is a region in the three-dimensional space that looks like this. That x moves between two numbers, the y moves between two constant numbers, and the z moves between two constant numbers, and what you get geometrically is a box. So the idea is we're going to start defining triple integrals over rectangular boxes by subdividing these rectangular boxes. So you have a rectangular box and you subdivide each one of the intervals of the corresponding variables, just like we did with rectangles. And the thing that we will obtain is a subdivision into smaller rectangular boxes. We subdivide in this way. We subdivide the interval AB into L subintervals of equal width delta x. We divide the interval CD into m subintervals of equal width delta y, and we do the same for the interval RC into n subintervals of equal width delta z. So the idea of the triple Riemann sum is we are going to divide the box into L times m times n smaller boxes. So the thing that we will have over here is that each individual box is going to be determined by which interval it is in the corresponding coordinates. And this is more or less how each individual box is going to look like, and the volume of that box is going to be delta x, delta y, and delta z. I mean, just the multiplication of the difference in the x, the difference in the y, and the difference of the z's. So pretty much that's what we have. Then the thing that we're going to do is we're going to define what we call a triple Riemann sum. Remember, this is just an extension of a double Riemann sum. So we're going to have each one of these boxes, and we're going to take a sample point inside of those boxes. We're going to take the sum of the value of the sample point times the volume of the rectangular box, and we're going to add all those values together. And that's what is called a triple Riemann sum. So now, how do we define the triple integrals over rectangular boxes? Well, let me just again say that a triple Riemann sum is given by the value of a sample point times the volume of each individual small box, and then adding all those multiplications together. So the triple integral over a rectangular box is going to be the limit when L, M, and N goes to infinity. In other words, is the limit when we take smaller and smaller rectangular boxes, or in another way that you can say it, we are subdividing the original intervals into more and more pieces. Well, again, we're going to have a way that we can get away from doing Riemann sums is by doing Fubini's theorem. So if you have continuous functions on a rectangular box, and the rectangular box looks like this: x goes from a to b, y goes from c to d, and z goes from r to s. The thing that we're going to have is the triple integral is just going to be the iterated integral using x, y, and z, and keeping in mind that you have to put the corresponding limits of integrations to the corresponding values. Let me give you an example. So suppose that we have this integral over this box. So again, the thing that we write first is this box as in a set notation. So x goes from 1 to 4, y goes from 0 to 3, and z goes from 2 to 6. And the thing that we do is we just choose a particular order that we're going to integrate. So here I'm going to integrate first with respect to z, then with respect to y, and then with respect to x. As in integrals with respect to rectangles, the order does not matter. So the z goes from 2 to 6, the y goes from 0 to 3, and the x moves from 1 to 4. So the thing that we have is, doing the calculation, I integrate first with respect to z, then evaluate, then integrate with respect to y, then evaluate, and then integrate with respect to x, and then evaluate, and the answer that I have is this number right here. So this is the way that you compute a triple integral over a rectangular box. Thank you very much.